Hi, I'm Justin Snedden from the AR team at Niantic, and today I'm going to walk you through how to get the depth buffer as a texture for use in effects. So, as you've seen in many of the demos, we use depth to generate things like the mesh, and you can query the distance to anything in your scene. There are many great uses of it. One of the neatest thing about it, though, is that you can write shaders that require depth for effects that you want to do. Maybe you want to do a depth of field effect or some kind of scanning radius or many other things that you might want to do there. I'm going to walk through this tutorial showing you how to get the depth buffer back efficiently as a texture for use on the GPU in a shader. I'm also going to do the same for the semantics textures in the next tutorial. So both of these things combined can be quite powerful when you want to make various compositing effects. So let's get started. As usual, I've assumed you've got a scene that is set up and works and can run on device. If you haven't got that set up, please go and look at the basic setup guide. There is also a video tutorial on that you can watch. So let's get going. First, we'll create a folder, and we will call this depth texture. And then in here, we'll just make a new scene again. Create a scene. Also called depth texture. Just open that up. Now, as always, we've got an empty scene. The first thing we always do here is we set this to solid color and we make this black to allow us to replace the background. As with every demo, the very first step is to add in the managers that we need to be able to run AR. So the first one is an AR session manager. This is the script that starts everything up for you and makes sure that AR is running. We are going to need depth because we want the depth buffer. So let's add a depth manager, AR depth manager, this is the last one here. And then we are also going to need the camera to be positioned in the right place when we move it. So that's the camera position helper, this one. We will want to be able to render as well. So rendering manager. If I spell it correctly, rendering manager, AR rendering manager. There you go. So with all these scripts added, as always, quickly check that you have set the camera. It's usually the position helper that doesn't auto detect this. Hopefully that's something that will be fixed in an upcoming release. Here we go. So now you've got all of your managers in. The next thing we're going to have to do now is quite a bit of scripting. So it's not difficult scripting, it's just a little bit more involved than the last few tutorials. We're going to have to make both a C# script and a shader. Not very hard. Most of you probably know how to do these things already. I'm just going to use an onRender command and drop a script on the camera that calls the shader, and that will render the depth on screen for us. And then we could start writing a post effect that used that texture plus the main texture from Unity to mix together to make whatever kind of effect that you would normally want to do when you composite and you need depth. So first thing, let's make a script. And let's just call this depth texture as well. Again, feel free to name these whatever you'd like. I'm being very boring with my naming scheme. So we open that script up. I'll just bring over my editor because it's on a different tab. There we go. No, I don't need to know any of those things. Right, so the script is going to be a pretty simple script. It will take in the depth manager, and then it'll hook a callback for the depth manager. So the very first thing we'll do is we'll say, well, I need a depth manager. So in here we'll say, please give me a depth manager. And then we will say from the depth manager, we want to hook depth buffer updated. So the way these managers work is they all have various callbacks. You can look at them to work out what they all are. This one gets called whenever a new depth buffer exists. So we're just saying when this event happens, please call my callback. So we define that callback in our class, which is very straightforward. We just say it's a function that takes in a depth buffer argument here. So this is essentially the crux of whenever a new depth buffer exists, this will get past some args. From the args, we can say, hey, I'd like you to turn that buffer into a texture that I can use. We'll need quite a few different namespaces for this to work. So let's just drop those in while we're here. We'll need a session args for the various things that are passed in. We will need a couple of awareness namespaces because we're going to be using the depth buffer. Let's drop these in, and we're going to need the extensions and helpers for the various manager classes, as well as the config for changing our config. So drop all of these in, and then we'll keep moving. At the moment, our script doesn't do anything. You could run it in editor if you want, but you're not going to see anything as yet. But it is a good opportunity for us to set up the mocking system. So before we start writing lots and lots of code, we probably want something that we can see in the scene in order to assume that our code works. So let's go back to the editor really quickly. So in here, we just want to add some objects. I'm just going to add a cube this time. You can drop in the test scene or any other thing you'd like. For simplicity, a cube will do for what we're about to build. So literally a unit cube that I'll drop in, and I'll set it to 0, 0, 0, so it's right bang in the middle of the screen, like this. So if we look at our camera, we've got a cube and nothing else. For the cube, we're basically saying this is a mock object, so add it to the mock layer. Again, if you don't have the mock layer, just add a layer here called mock, and then set your object to that. This is because we remove this layer when we run on device. So we go back to our camera, we look at the culling mask, and we say we do not draw the layer called mock world. So now we have this object here that we can use in the mocking system. And again, if I just run this, I should just see a big square. Why is this? Yeah, so I just moved the cube back there by 2 just to so that you can see it when you run it. So before, when I ran it, the cube was actually behind the camera because the camera was positioned at 0. So you either inside or just behind the cube. So I've moved the cube back by 2, and as you can see, we've just got a big square cube on the screen, which is what we want, because the shader we write will essentially just turn this to a grayscaled cube. So nothing amazing, but at least we'll have something to see. Right, so let's go back to some scripting. Now, I should say, before we go and write this tutorial, the whole point of it is not to just visualize depth. If you do want to just show the depth buffer, there's actually a built-in function for that. So without doing any difficult code, we could just say, hey, depth manager, can you show me your debug mode? So this toggle debug visualization, we set this to true. That will just draw it. There's a bunch of code already in there to display just the depth texture. So if I come back in here and I run this in Unity with just that function call switched on, just give it a moment while it thinks. There we go. It will get a grey overlay. So we would get a grey overlay if I added the script to any object in the scene. So any of you that have been watching the multiple of these tutorials, I continually forget to do this, which is we created the script, but we didn't add it to a scene. So it does nothing unless you drop it in the scene. It doesn't have to be on the camera. As I always say, I'm just putting them here so they're all in one place. It makes it easier for me to demonstrate. It's not necessarily how you have to set up your scene. The only objects that really need to be together are the rendering manager and the position helper. All right, anyway, let's keep going. Now that I've put that into the scene and the script will run, we should get a grayscaled object. So now, rather than a colored image, we're seeing the debug manager turn on its debugging mode and show you the depth texture, which is what we expect. This is a solid gray color because it's a square. All of those points are at the same depth away from you, which is why they're the same color gray, which is what we're after. Now, when our tutorial is over, we're probably going to be back at the same point we started, but we'll have done this in a completely different way. And the key difference here is if you just want to see depth, just do what I did here, which is you come into the code and you go, show me what the depth buffer looks like by toggling the debug mode. If you want to use the depth texture for something, that's a different request. You're saying, I want on the GPU a copy of the depth buffer, and I don't want to do any CPU stuff or anything like that. It's just make this texture and leave it on the GPU. So it's much more efficient to do what I'm about to show you for that use case. So let's just get rid of that for now. And what we want to do is fill in this on update function to say, hey, when you update, give me the awareness buffer. So you say, hey, from these args, you can ask for the sending object and So you go args.sender awareness buffer. Now, the reason why this is generalized and then I make it specific here is because we also have different types that could be passed in here. In this case, we're catching the idepth buffer. When we write a version of this for the semantics, this would just be isemantic buffer, but this part of the code can stay the same. So it makes it easier. You could put var here if you're a particular C-sharpy person. I have a C++ background, so I kind of like to write types. I find that helpful. You don't have to. You can put var there or write it however you'd like. So now that we've got this, what we want to say is, okay, turn that buffer, what it's actually stored is a bunch of floating point numbers. But what we want is a texture. So we call a help function, which is called create or update texture. There are two variants of this. I'm asking for rfloat, which is a texture type that is supported on most phones. But if you want an ARGB texture instead, you can also get that. So rfloat just means it's a large depth single float texture rather than which means I can pass whole numbers in. So for example, I can say that the depth is 4.562 meters, and that could be pushed directly into this texture. Whereas if I wanted ARGB, I need to normalize it first. So just for completeness, the equivalent call for that looks like this. There's a lot more code, which is why in the example I'm using rfloat, but essentially saying get the near and far camera plane, and then normalize the values that are in the buffer across those. So we have this similar function, which is create an ARGB32 texture, pass in the reference, and you have to pass in this little inline function here to say, how do I normalize this? So across that min and max, we're just saying average it. So ARGB32 can only be from 0 to 1 in the values. So all this is doing is dividing it linearly across that space. I'm going to continue to use the rfloat version because it's less typing. So I'll just get rid of that for now. But if you do need it, there was an example of how to use it. And as with all these tutorials, there is a text version. So if you miss anything, it's in the notes, so you'll be able to find it. Anyway, so what this has done now is every time there is a new depth buffer provided, it will turn it into a texture, and it'll store it in this texture reference that we need to create, because I didn't put one in the scene. So we need a 2D texture up here. So texture 2D, and I called it depth texture. Right, so now what we've got is a script that will store our texture. The next thing we want to do is probably draw it. So as I said, we'll just do a very simple blit from an on-render. Since I've dropped this on the camera anyway, we can just add in an on-render statement in here like this. So very standard Unity stuff. This will just get called when and pass through from Unity to do our rendering. To set up the shader, I'm not going to do anything dynamic. I'll just pass in a material that has a shader that we make on it. So let's just add a variable for our material called shader material up the top. And then what we'll do is set some values on it. And the value is quite simply just going to be pass in this texture and pass in some transforms. So the depth buffer that gets returned here is not rotated or played with in any way. So it's exactly what comes out of the machine learning model, which may not be the alignment that your camera currently is in. So what we have to do is when we work in the shader, we also pass in a transform that lets you take this texture, which may not be uniform. Like the machine learning model doesn't actually return the same aspect ratio or even orientation as your phone. So we also give you a matrix that you can multiply the UVs by when you're in the shader to just rotate and crop everything neatly. And the way you get that is from the depth manager itself. I'll just quickly paste this in and then show you what syntax is. So again, I'm passing in a matrix. I'm just going to call it this in the shader. So you ask for the depth manager that we've passed in, and it has an object within it, which is actually not called that anymore. Sorry, I'm using the wrong depth processor, which is inside the depth processor. This is the internal piece of code to the depth manager that does a lot of the calculations. And you say, hey, give me the sampler transform, which is just the matrix 4x4 that we can use to multiply our UVs, as I said a moment ago. And then all we need to do is blit this. So the same, blit source destination and pass in our material. So graphics.blit. Yep. source, destination, and the material we've just made, we've set these two parameters to. We'll now just make that shader and make those materials and pass them into our script. So if we quickly just drop back to Unity and just check I haven't missed any namespaces, which depth processor not found. Okay. The API had slightly changed since the alpha version I was using. So the correct term here is depth buffer processor. So it's just the object's been renamed since the last time I wrote one of these tutorials. Anyway, so come in here, you say, hey, depth manager, give me the internal processing object, and from that I want the sampler transform. You pass that through, and then in the shader we can use this matrix to do our UV rotation and cropping. Right, so save all this. Let's go back to Unity now. And what we want to do is make a shader. So the first thing we'll do is we'll make a material, and then we'll add that shader that we are going to write to it. Let's just call this depth texture. Awkward name for a material. We'll put matte on the end so it's a bit clearer. And then we'll make a shader. So shader, it doesn't really matter which one you pick because I'm going to replace all the code in it anyway. And let's just call this a depth shader. Right, let's click the material here. In there, we'll just set it to our newly created depth shader, so that now this material knows that it's going to use this shader. And while we're here, we might as well set our shader variable to that new shader, the new material that we just made, which was called depth material. Here we go. So now everything's connected. We now open the shader and have to put a bit of code in it. So I'll bring this over here. We're basically going to delete everything in here other than the name of the shader. So we won't be doing any of these things. Right. We'll be passing in that texture that we mentioned before, the display transform that we need to multiply the UVs by to get the correct orientation. I'm just going to drop in a whole bunch of code now because it just saves me typing, and I'll just talk through it. And as I said, there is a version of this, text version of this, so you can look at it at your leisure if you miss anything when I'm going through this. But basically, this passing the main texture, Unity will inject this. That's the normal Unity scene. Depth texture is the one that we're going to pass in from our blit function. We're turning off all of the culling in the test because we don't really need them. We're just going to draw a 2D texture across the whole screen anyway. I want to use a vertex program and a fragment program. The vertex program will be used to do part of the rotation that we talked about. Normal in and out for our shader. I've added one extra variable here for the depth UV. This is the converted one. So this is what Unity passes in. We'll need to multiply that by the transform, and then put the answer in here. It's a 3D because we will be using the Z component for some normalization. Here is the transform that we said we would pass in. Here's our vertex shader. The first part is a normal vertex shader, pass through some stuff. The last part is the multiplication we were talking about. So there's a multiplication using that transform, and that we want to take the input UVs that we have and multiply them by it. Now this needs to be a 4x4 here, so just a float 4 and then a 1, 1. And it's 3 dimensions that we want back, so X, Y, Z, and that gets stored in here. Then we have our normal sampler. This is the texture that we're passing in. In our fragments shader, we knew a little bit more math just to take this 3-dimensional position and make it a 2-dimensional one. And all we do to get that is just divide the Z through the X and the Y. So that will normalize it down to be the right positioning. Now that we've got that, we're basically from this point a normal shader. Say, text 2D, sample this texture at the coordinates we said and return that value. So now what we've got is basically a grayscale texture that should look the same as what we had when we ran the debug mode one. But the difference here is we now have a on shader side, GPU side texture that we can use for effects. So we could write an effect that requires depth, here, and it's not costing us very much. So anyway, if we come back to here, hopefully I don't have any errors. Yes, good, we're running. And if I run this, I'm probably just going to see a cube. Well, we can't see the cube. We can't see the cube because it's just a bit too big, I think, for the positioning we've got it in is a bit strange. So let's just change some settings here so we'll make it visible. Instead of 2, I'm going to move it about 1 meter back, and I'll make it smaller. So I'll just make it like half size. I think that should hopefully make it visible. If I run this again, what do we got? There you go. There's your cube. It's on the screen. And that's it. So yeah, it says there's a depth buffer. So the further away, the harder it is to see it. We've now got this in a texture, and because we have it in a texture, we can do all sorts of great things. It would be very easy to write a blur based on distance. So if you wanted to make similar to a depth of field effect, you could say anything between 1 and 5 meters is very much in focus, and anything beyond 5 meters is very blurry, and anything in front of 1 meter is very blurry, meaning you can set a focal point, and you could do that by, you could also pick, like you could click a point on your scene and say, hey, focus on that thing. So give me the depth of that thing, and anything behind or in front of it, blur it out. Nice little simple effect. Or things like scanning, like an alien scanner style thing that runs a line through the world. You could basically draw a red line that just pulses based on a sine curve or something similar through the entire scene. So it would draw it across the world because you're using the depth map for that you've passed into your shader. But those are all things that you can do. Quite possibly in a later tutorial, I might make some similar demos like that. But for now, that's the end of it. We've said, hey, depth system, give me a texture that I want on the GPU to draw. Now, the way I've done that, again, is not necessarily the best way to do your graphics. It was an example to say, this is how you get the texture for use on the GPU. I'm sure plenty of rendering engineers out there know how to do this stuff way better than I do. And as usual, let's just run it on the phone just to prove that it does all work. Okay, so there we go. Here it is starting up on my phone. So hopefully what we see here is a depth buffer. Well, there you go. It's all working, and yeah. Now you have a depth buffer on your GPU that you can use for whatever effect you'd like to do. That's the end of this tutorial. Hope you had fun playing with ARDK.